Hi friends, welcome back to new session. In this session, we'll discuss some previous DC missions gate questions. Let us the first question. 50 kilowatts DC shunt motor is loaded to draw rated current at any given speed. When driven at half of the rated speed by the armature voltage control, and in second case he's saying that at 1.5 times rated speed by field control, the respective output powers delivered by the motor are approximately. See guys, I already told you, if you want, please try to refer speed control of DC motors. There I told you by armature voltage control method we'll be having below rate speeds, and by field control method we'll be getting above rate speeds, And see, let me draw a graph which I already discussed. So so let me take an y-axis power comma torque, and x-axis let me take speed here, and here let me take rated speed, here greater than rated speed, here less than rated speed. Okay, see, so I already told you in armature resistance control method, or I can say armature voltage control method, we'll be getting below rated speeds, nothing but in this region. So in that case, machine motor acts as constant torque comma variable power drive. So let me draw that graph. In a below rated, I'm saying, just try to understand, in a below rated speed, actually in armature resistance control method, in armature voltage control method we'll be getting below rated speeds, and in for field control method I'll be getting above rated speeds. So in a below rated speeds, machine motor acts as, I can say, constant torque. Yes, it's a constant torque and a variable power. So let me take another color here, variable power. That too, you please try to see, as the speed increases your power will be increases. Okay, so if you want, please try to refer that the speed control of DC motors, there I explain this graph. And in above rate space I told you, machine motor acts as constant power comma variable torque. So this becomes constant power and variable torque. That too, if you observe, yeah, in above rate speeds, as the speed increases, your torque will be reduces. So you are going to have some rectangular hyperbola relation. So you are going to have a graph like this. Yes. Okay, the torque. So now what is asking in this question? In first question is saying that, so when driven at half of the rated speed, so that means this is what I can say first case. Okay, and second case, at 1.5 times rated speed means above rated speeds, I can say that this greater than rated speed, nothing but second case. Okay, so the respective output powers delivered by the motors are approximately. So it's very simple. In a second case, I mean to say that in above rate speeds, or I can say greater, 1.5 times this rate speed, whatever I'm getting by field control. So that but above rate speeds, here machine acts as motor acts as constant power. So in second case, I can say second case, your answer is same constant power. So water 50 kilowatts is there. So same will get here. So in second case, 50 kilowatts. So tell me which option contains 50 kilowatts per second case. I think option B and option D. Let me check among B and D which one is correct. So obviously A is wrong and C is also wrong. Let me check among B and D which one is correct. So in case 1, so that means at half of the rate speed by armature voltage control method, so he's asking power. So guys, in below rate speeds, I already told you that your power is directly proportional to speed. As the n increases, your power is increasing. So I can write P proportional to n is relation. So in for first case, I'm saying P proportional to n is relation. As n increases, power is increasing. So try to understand. He's saying that at half of the rate speed, that means he is reducing speed by half. That means he's making speed, speed is reducing by half. So power also reduced by half. So what about your answer? So power reduced by half means what? 50 by 2. So 25 kilowatts is the answer. So option A, sorry, I'm saying option among option B and option D. Option B contains 25 kilowatts in case 1. So obviously B is correct one, but whereas D is wrong. Okay. So I told you already second case where of 1.5 times rated speed, nothing but greater than rated speeds. Your answer is how much? 50 kilowatts only. And in second, in case one, your answer is 25 kilowatts. So option B contains 25 kilowatts in one and 50 kilowatts in two. So B option is correct one. Okay, right. Next question. It's a very simple question. In a cumulative long shunt motor is driving a load at rated torque and rated speed. If the series field winding is shunted by resistance equal to the resistance of the series field. Example, let us assume that this having resistance RS value. What is saying that is connecting some shunt ratio across your series field winding. What about resistance value also once again RSC value only. So keeping the torque constant, this term is very important. Okay. So you know relation guys, Tm proportional to pi into Ia, pi into Ia. So what is asking now here? So he just might want to maintain the torque constant. So torque is constant here. So now tell me if you want to maintain the torque constant, try to see what is asking. If the series field winding, the series field is shunted by resistance equal to the resistance of the series field means. So tell me guys, you already know that cumulative compound means total force equals what I can write pi sh plus pi se. Okay. Now tell me here, series field winding is shunted by resistance equal to the resistance of the series field winding. So RSC is the value which is shunted across once again RSC. Okay. So obviously now tell me what is the current flowing through series field winding will be reduced. No? Whenever it is reduced, because previously RSC, now it is shunted by resistance. So obviously current will reduce here. So pi SC will reduce. So that means total flux will reduce. So obviously Ia will be increases to maintain the torque constant. So your answer, the armature can increases. So option A is the right answer. Okay, option A is the right answer. So see previous question asked in GATE 2005 for 2 marks. This is the question asked in GATE 1993 for 1 mark. Let us see this question. A 4-pole lap wound DC generator has given poles how much? 4. And 30 mentions a lap wound. It's a lap wound DC generator. Has developed power of P watts. He's saying that if winding is a lap winding, so let me write here. So power in case of lap, how much is saying? P watts. Okay, P watts. And voltage of how much is saying? E volts. So voltage in case of lap winding, how much is given here? E volts. E volts. Now what is asking? Two adjacent brushes of the machine are removed as they are worn out. See, because they are damaged, so two adjacent brushes of the machine are removed as they are worn out. If the machine operates with the remaining brushes, the developed voltage and power that can be obtained from the machine are. So guys, you try to understand one thing here. Since it is a lap wound, you know number of parallel paths. So I just indicate number of parallel paths with A. We want to write here number of parallel paths. Number of parallel paths is equals to what? Number of poles. Number of poles. So how much has given? 4 poles. So I can write here number of parallel paths and take 4. Okay. And for lap winding, please tell me number of brushes. Number of brushes equals so much. So I think I had already given in the construction of DC machine. Please try to refer that. Number of brushes equals number of poles in lap wound is equals once again 4. Okay. So let me take here 4 parallel paths and 4 brushes. 4 parallel paths and 4 brushes. Yes. So let me get here. Yes, brush 1, brush number 2, 3, and 4, brush number 4. Okay guys. Okay. And I think he has not given any number of conductors. Okay. Let us assume that 4 conductors are there. 4 conductors are there in each parallel path. See, these are nothing but number of parallel paths 4 I have taken here. 1, 2, 3, 4 I have taken. Okay. So in one parallel path, let me take one conductor. So he has not given conductors, not issue. So let me take 4 conductors here. 4 conductors. Yes. Let me connect here one conductor in one path, another conductor in another path, okay, and one more conductor in another path, one more conductor, another path. Okay, right. Next, so let me take here brushes polarities also. Let me take plus, minus, plus, minus. Okay, guys. So let me connect plus brush, plus, and a plus. I just connect together here. Okay, and minus terminal is connected once again minus here. So let me take two terminals outside here. Yes, one. Let me take this one as plus terminal, and let me take this one as a minus terminal. Okay, minus terminal. So guys, here try to understand simple thing I'm saying here. See, suppose example. Let me use laser point here. Okay, suppose if this brush is damaged, okay, this conductor and this conductor becomes dummy. Because if this brush becomes damaged, there is no closed path for this for the current from this conductor no. So what I'm saying is, if one brush is damaged, the conductors which are connected to that brush will become a dummy here. Okay, suppose if this is damaged, this and this becomes dummy. If this is damaged, this and this becomes dummy. If this is damaged, this and this becomes dummy. Now this question, please tell me how many brushes damage is it? Two brushes of the machine are removed. That too, he is saying adjacent brushes, not opposite brushes. Okay, he is not saying opposite brushes, he is saying adjacent brushes. Okay, let me take adjacent means this one and this one. Okay, this one and this one. Please take this one and this one. So this one is damaged, this one is damaged. So please, if you take like that, now tell me. Let us take this one is damaged here. Let me take this one is damaged. So first of all, if this is damaged, so this becomes dummy and this becomes dummy, as I told you, right? If this is damaged, once again, this becomes already dummy and this becomes one more dummy. Okay, so ultimately one parallel path is there only in active mode. Okay, if two adjacent brushes are one node. Okay, that thing you should know. Okay, so if you know the small logic, then you'll get answer very easily. Okay, let us see. Suppose if it is difficult for you to follow like this, so let me draw same thing. I'll draw in like this. Let me take one conductor, another conductor, another conductor, another connector, which are connected in four parallel paths like this. So without having brushes, I'm just simply showing connectors here. And let me take this one is load. Let me take this one is load. Okay, let me this one is load. So let us assume that your load current is IA value. Since I'm having four parallel paths, so current coming from one parallel path, I'll take it as IA by 4. Here also IA by 4. Okay, here also IA by 4. Okay, here also one more IA by 4. The total becomes, I can say, IA. Okay, and tell me guys, what is the voltage? He said actually E volts, no? E volts. So please try to understand here. Try to understand. Suppose across this conductor, I can take what is the voltage means. Let me, if you want, I'll take this value as E volts. E volts. Here also once again E. Okay. E volts. Here also E value. Here also E value. Okay. I mean to say across this E volt, across this E. So like this one is E volts, this one across this current I can take E volts, across this I will take E volts, across I will take E volts. So what is the voltage across? I can say load, I can say once again E value, no? E value. Okay. Now please tell me what about power at load I'm saying. So if you want to find point for power, so power equal to what is the formula? I can say E value, load voltage E into IA value, right? So E into I. So please try to understand P equals what is the formula here? E into I. So in this case, load power is a P. Okay. Let me use some other color. It's not visible. Yeah. You can say P. Power is equals what I'm saying? E into IA. So power is a P and voltage is E. Okay. Now here I'm saying here, because of two adjacent brushes are removed, so here this becomes dummy and this becomes dummy, this becomes dummy. Okay, so ultimately only one path is there in the active mode. So let me draw now. So now please tell me answer after having this discussion. So let me take only one. These three becomes dummy. Okay, let me take a, yeah. these three becomes inactive mode now. They are because these two adjacent brushes are worn out. So these three parallel paths becomes inactive now. So only one parallel path is there inactive. Okay. So now please you can write. Yes. Let me show once again. Or I'll show, but I'll make inactive three parallel paths. Okay, guys. Yeah. Now tell me, I told you voltage about this much. About what is the voltage across this conductor? E. Here also E. Here also E. Here also E. Okay. Across this load also, I told you how much here? E value. And what is the current flowing through each parallel path? IA by 4. IA by 4. Okay. Here also IA by 4. Here also IA by 4. Here also IA by 4. Okay, now I told you it becomes these three becomes a dummy now. So tell me, so what is the current coming only at the load side now? Please tell me what is the total current coming at the load. You'll be getting only IA by 4, IA by 4, IA by 4. And tell me if you want me to find out power here, power in second case, power in second case, you can say P2, something like that, P2. So voltage is how much here? E only. And what about current here? IA by 4 only. IA by 4. IA by 4. Already I took E into IA means how much I taken here. So P value becomes what I can say P by 4. P by 4. P by 4. So now tell me what is your answer? So if two adjacent brushes are removed at their worn out, so our answer is voltage is E volts only, because see, let me use laser point here. Yes, voltage is E volts only, and the power becomes E into current is IA by 4, therefore it becomes P by 4. So our answer is E comma P by 4. Option C is the answer. Okay, option C is the answer. Okay. So a simple thing only, please don't confuse, very simple thing only. Suppose in this question, suppose if I ask you two opposite brushes are worn out. Suppose if I take opposite brushes worn out, then at that time answer will be, tell me, can you please tell me answer? If two opposite brushes worn out, suppose if I take these two brushes are worn out, because of this brush is damaged, this two becomes dummy, and because this brush is damaged, this two becomes dummy. At that time voltage becomes 0, power also becomes 0. That's it. Okay, suppose if only one brush is worn out, example if I take this brush is only worn out, these two becomes dummy, whereas this is in active mode, this is also in active mode. So current IA by 4, IA by 4 becomes IA by 2. So at that time your answer is E comma P by 2. Your option may be D if only one brush is worn out. Try to understand. If only one brush worn out, your answer is what I am saying, E comma P by 2. If two adjacent brushes are worn out, means your answer is E comma P by 4. Option C is the answer. If two opposite brushes are worn out, means your voltage becomes 0 and the power also becomes 0. Okay, a very simple thing only, guys. So try to understand. There is nothing to confuse here. Okay, so option C is the answer for this question. Now, a separate excited DC generator has an armature resistance of 0.1 ohm. So please let me write the value here. So he has given armature resistance for how much? 0.1 ohm, and that we mentioned is a separately excited DC generator. Separately excited DC generator. He has given armature resistance 0.1 ohm and negligible armature inductance. So LA has given 0. Okay. And at rated field current and rated rotor speed, its open circuit voltage is 200 volts. So he has given open circuit voltage how much, guys? So 200 volts he has given. Try to understand, this is the voltage he has given at rated field current and rated speed. That means something at pi comma, okay, rated speed means I can say n. So rated field current means correspond to rated field current, I'll take it as flux means pi. Rated rotor speed means I'll take speed as n. So whenever speed is n and pi, nothing but rated speed and rated field current, at that time your EOC is value is 200 volts. But what is try to understand, guys, when this generator is operated at half the rated speed, now actually generator is operating generator is operating at what? At half of the rated speed, at n by 2, okay, with half of the rated field current, that means pi by 2. So guys, whenever n becomes n by 2, pi becomes pi by 2, can you please show what about open circuit voltage? So you already know E proportional to n pi's relation, no? So no, E proportional to n pi's relation. Okay. So suppose if n becomes half and flux becomes half, so E becomes the 4. I mean by 4. I mean it reduced by 4 times. Therefore, EOC is nothing but 200 by 4. Your answer is 50 volts only. Okay. Now I'm saying if it is operating at n by 2 comma pi by 2, your open circuit voltage is 50 volts. Okay. So with half of the rated field current and half of the rated speed, its open circuit voltage is 50 volts. Okay. So that's the one. That's the one you have to remember. And guys, let me take separate exit DC generator once. Let me draw once again so that you'll be having some clarity. This is what I can separate exit DC generator. I'll be having separate field winding. So separate DC source for connected to the field winding for exercise purpose. And here is the armature, brushes. So let me cut some load here. So he clearly mentioned in this question, when this generator is operate half of the rated speed with half of the rated field current, and uncharged 1000 microfarad capacitor suddenly connect across the armature terminals. So he connect here how much capacitor value? Please tell me. So I think 1000 microfarad connected across armature terminals suddenly. Okay. Assuming that the speed remains unchanged during the transient, at what time microseconds after the capacitor is connected will the voltage across it reaches 25 volts. Okay, he's saying I mean after how much time your capacitor voltage becomes after how much time capacitor voltage becomes 25 volts, like this thing, 25 volts, like that is saying. Okay guys, very simple question only, try to understand. So for that you need to know one simple thing here. So I think I had given you one form. I mean, if you know one, I think in network theory you might have studied one formula. Capacitor voltage is equals to generally V naught into 1 minus e power minus t by tau. Tau means here I can say it's a, because the ratio, armature ratios is there and capacity is there. Let me take RC. So VC equals V naught into 1 minus e power minus t by tau. So where tau is, I think I say RC. RC. Okay. So here, so this capacitor voltage, how much he has given? I mean, after how much time this capacitor voltage becomes 25 volts means, yes, this is the final value of your capacitor final voltage. Let me take 25 volts here. And tell me initially how much, what is the voltage across your capacitor? That means this one. So how much voltage? So initial, after whenever it is connected, suddenly connect across your armature terminals, its initial voltage is 50 volts, because whatever EMF induced in your generator, so across that armature terminals only connected capacitor, no. So this is what I can say initial voltage I'll take. So 50 volts into 1 minus e power minus t by RC. So RC means how much armature resistance he has given? 0 0.1, 0 0.1. And how much capacitance he has given, guys? I think he has given 1000 microfarad, right? 1000 microfarad. 1000 into 10 to the power of minus 6. Okay, right. From this, if you do calculation, it's very simple. You'll get time constant, and you'll get time value, t value, you'll get 69.3 microseconds you'll get. That means after 69.3 microseconds, so your capacitor voltage will reach 25 volts. Initially, how much voltage? I can say 50 volts. Now after 69.3 microseconds, your capacitor voltage it reaches to 25 volts. Okay, so your option 69.3, option B is the answer. So it was a question asked in 2015 for 1 mark. Okay guys, right. Next, let us this question. A 4-pole. So he has given poles how much? 4-pole separately excited machine. It's a separately excited DC machine, wave wound DC machine. So initially is a wave winding with a negligible armature resistance is rated for 230 volts. So guys, he has given when windings are wave winding, when armature winding is wave wound, I can say E wave. He has given how much? 230 volts he has given. And power also has given how much? Power, I mean power, if winding is a wave winding, so how much has given? We have 5 kilowatts, 5 kilowatts. at a speed of 1200 rpm. So speed when armature winding is wave is, he has given how much? 1200 rpm he has given. Okay. Next, if the same armature coils are reconnected to form a lap winding. See, the same armature coils reconnect means, so your number of conductors, I mean number of armature conductors will be same. So Z becomes, I can say here, same. So for lap and wave, Z is same. Same for lap winding and same for lap and wave. Okay. What is the rated voltage in volts and power in kilowatts? So respectively at 1200 rpm of the reconnected machine. So he said initially it is wave winding. If the same armature coils are reconnected to form a lap winding. So whenever wave winding is changed to lap winding, is asking E lap is asking, E lap is asking, and no, power in lap also is asking. Okay, so when winding is changed to lap winding, so in lap winding speed he has given how much, guys? In, I mean, lap winding speed how much he has given? 1200 rpm. 1200 rpm has given, same as that of wave winding. And one more thing he mentioned: if the field circuit is left unchanged, try to understand, guys. Whatever DC supply given to the field winding in a separately excited DC machine, so that if the field circuit is left unchanged means, what is the meaning for that? Flux remains same. Flux is same for lap and wave. For lap winding as well as for wave winding, flux is, I mean, flux is same. Okay. Now he's asking to find E lap and E wave. So without doing any calculation also, simply we can say answer for power output for lap winding, I can say easily, because I told you guys try to refer lap winding, wave winding. So for lap or wave, so power will not change. For lap or wave, for lap winding or wave winding, power will not change. Since P wave is 5 kilowatts, so P lap also will be 5 kilowatts only. So he's asking first one voltage. No, first is asking what is the rated voltage, and second is asking power. So second case here, I mean power is asking kilowatts. So option A, option B contains 5 kilowatts. So option A, option B, either option A or option B should be your answer. So option C, option D is wrong. Let me check among option A and option B which one is correct. So that can be understood by calculating E lap. Okay. So tell me, guys, what is the formula for induced EMF in case of DC machine? Pi Z N P by 60A. Okay, so he said in the question, so flux is constant. Okay, flux is constant, number of currents also same. Okay, and I think speed also constant. No, see, speed has been 1200 rpm. Here also has got speed also 1200 rpm. So speed also same. And as usual, number of poles, because same machine is using for lap winding, so everything is constant here. Now obviously your E proportional to what? 1 by number of parallel paths. Okay, so E lap by E wave is equals to what? A wave, number of parallel paths in wave winding by number of parallel paths in lap winding. Okay, so guys, I already told you number of parallel paths in wave winding, how much here? This will be equals to 2. Number of parallel paths or lap winding is equals to number of poles. That is equal to how much he has given? Number of poles, how much he has given? 4 here. So please try to refer lap winding, wave winding. There I told you number of parallel paths for wave winding is 2. Number of parallel paths for lap winding is number of poles is equals to 4 in this question he has given. Okay. So therefore, what's your answer? So I think E lap is equals to, let me change the color. Okay, E lap is equals to 2 by 4 into, let's say E wave. What's the value of E wave he has been in the question? So 230. This value has been 230 volts. So 2 by 4 means 1 by 2. So 230 by 2 means 115 volts is the answer. Okay, so 115 volts and 5 kilowatts. So option B is the answer. Option B is the answer. Option A is also wrong here. Okay, so voltage becomes 115 and power becomes 5 kilowatts. 115 volts and 5 kilowatts. Option B is the right answer. Okay, guys. Now let me go for next question. It's a 240 volts DC shunt motor. 240 volts DC shunt motor. So DC shunt motor What is the armature resistance he has given? RA value how much he has given, guys? 0.5 ohm has a full load current of 40 amperes. He has given full load current how much? 40 amperes. 40 amperes. Now what is asking? Find the ratio of stalling torque to full load torque. He's asking to find the stalling torque. T stall by TFL is asking. So is equal to how much is asking? When a resistance of 1 ohm is connected in series armature. So what is the extra resistance connected in series with armature? I think 1 ohm, right? 1 ohm. So guys, let me take a DC shunt motor here. DC shunt motor. DC shunt motor. Here field line is connected across your armature. Yes, I can say plus minus DC supply connected. Plus minus DC supply connected here. IL value. Here IA value. I can say ISH value, ISH. So nothing but RSH value. Okay. So here, so please tell me what is the KVL equation I can write for this loop? So because of in motor, because of generator action, some EMF will be induced. That EMF can be called as back EMF. So V equal to formula EB plus IARA is the formula. IARA is the formula. Okay. Without having accelerations. If I did not grant accelerations in series armature, so V equals EB plus IARA is the formula. So guys, what is the formula for EB here? Pi ZNP by 60A. See, stalling means during starting condition, what is the value of speed here? 0. What is the value of back EMF? Also 0. So guys, please tell me during starting condition, I can say during starting condition, during stalling condition, like during starting condition, starting condition. So what is the value of back EMF? EB becomes 0 here. So please tell me what is the value of here V equals, I can write 0 plus I'll write this IA as IA stall, or I guess IA stall into RA. Okay, right. Here IA stall is equals to what I can write here, V by RA. V by RA. One thing you have to understand here. So generally formula what is the formula for IA means? IA equals to, let me use another color here. Yes. IA equals to, generally I'm saying V minus EB by RA is a formula. So guys, whenever back EMF becomes 0, okay, this IA value is very, very large. So to reduce this high starting currents only, we are adding some action resistance value in series with armature. Try to understand? During starting condition, since back EMF is 0, so IA value is very, very large. To reduce this high starting currents, we are adding some extra resistance value in series with armature. So that's the reason why we have to connect some external resistance value in series with armature during starting condition. So I think now it is justified. So that's the reason why I'm just going to connect here some starting resistance. I'll call that resistance value is how much here he has given. REX value how much he has given? REX, this value how much is given? 1 ohm he has given. Okay, 1 ohm. So now tell me this formula, this equation becomes V equals EB plus IA into RA plus what? REX, extra resistance value. Similarly, during starting condition, like I said, here EB is 0, okay. So V equals 0 plus IA star into RA plus REX. Now please tell me IA star equals to V minus 0 by RA plus REX, extra resistance value. Now tell me what about this value? I think he has given V value how much voltage? 240 was 240 by RA value how much he has given? Armature resistance value 0.5 plus. So what is the value of RX he has given? 1. So please try to understand this is nothing but 240 by 1.25 is the, well, 240 by 1.5 is the value of your IA star. Okay guys. Now one thing you have to understand here, in a DC shunt motor, general what is the formula for this ISH? ISH is equals to, supply voltage V by RSH. Okay, please try to understand. So if you want ISH value, let me use laser point here. So if you want ISH value, what is the voltage across this shunt field winding V value? V by RSH. So let me write here V by RSH. IS is equals to V by RSH. So in this question, he mentioned that the supply voltage, there is no change in the supply voltage, right? As long as supply voltage is constant, I can write your IS also remains constant. So your flux also remains a constant. See, ISH is remains constant here. IS also remains a constant. Okay, and the flux remains constant. So try to understand that is a very important point here in this discussion. So you should take a flux is equals to constant here. Flux equals to constant in this discussion. Okay. If you know that small logic, then you'll get answer. So what is asking now? Is asking find the ratio of stalling torque to full load torque. First of all, tell me guys, what is the relation I can write? What is the relation you are having for torque? T proportional to Tm proportional to pi into Ia is a relation, right? Tm proportional to pi into Ia is a relation. Okay. So please tell me whenever flux is constant, so I can write T proportional to Ia only. Therefore, T stalling torque by full load torque is equals to what? Ia stall by Ia stall by I can say full load current. Yes or no? Whenever pi is constant, simply T proportional to Ia, no. T stall by TFL is equals to, so I can write Ia stall by IFL. So tell me what is the value of Ia stall value? I mean, just now we calculate here 240 by 1.5. And what is the value of IFL as given in the question? 40 amperes. 40 amperes is the value, okay? So please tell me, so Ia stall by IFL means, I can write here, Ia stall value how much? Otherwise I'll give a remark and I'll write here only. Yes, please tell me Ia star value how much? So 240 by how much? 240 by 1.5 is the value. Okay. And what about IFL value as well in the question? 40 amperes. 40 amperes. Okay. So now tell me what about your answer? T star TFL equals to 240 by 1.5 is the value of ISTL by 40. So you'll get 4. So answer is 4. Your answer is 4. So please do calculation, tell me, just try to decide yourself. So your answer is 4. So option A is the answer. Very simple question only. So T proportional to IS relation here. T stall by TF equals IS stall by IFL. IS stall means 240 by 1.5. And here IFL, well, IFL full load he has given the question 40. So 240 by 1.5 is the value of IS stall by 40. That gives you answer. So 4 is the answer. Okay, right. Let us see next question. Yeah, a DC shunt motor is running at 1200 RPM. So here, try to understand. This is DC shunt motor. It's a DC shunt motor. DC shunt motor. Plus minus the DC supply given. Here is IL value. And here is the IA value. ISH value. Okay. RSH value. So a DC shunt is running at 1200 RPM. So he has given initial speed. How much he has given? 1200 RPM. Right, very good. When excited with 220 volts DC. So suppose initial voltage he has taken 220 volts here. 220 volts. At that time it is running at 1200 RPM. Neglecting losses and saturation, the speed of the motor when connected to a 175 volts DC supply is. So I mean N2 is asking when connected to V2 value 175 volts is okay. So guys, generally where people are doing mistake in this question means is actually a question in GATE 1999 for 2 marks he asked this question. So very simple. Generally people are thinking generally you will be taking a DC shunt motor means will take flux as constant. Try to understand. So you no doubt actually flux is the constant, okay, but try to understand small logic here. So what is the voltage applied? What is the voltage across your shunt wheel winding here? V value. So what is the formula for ISH? IS equals to V by RSH. V by RSH. So previously I took IS is constant, flux as I take flux I took constant. That is okay, but that condition is valid as long as your supply voltage is constant. Whenever supply voltage is constant, so ISH remains constant, flux remains constant. That is okay. But in this question, he is changing supply voltage. Initially, he applied 220 volts. Next, he is applying 175 volts. So guys, try to understand the small logic here. So please try to understand, what is the relation, for speed? N proportional to EB by pi is the relation. EB by is relation. Okay. N proportional to EB pi is relation. So here, yeah, and what about EB formula? You know, EB means what? V minus IARA by flux here. So I should not take flux. I should not take flux constant in this question because his supply voltage is changing. No, I should not take flux as constant here. And one more thing, guys, since he is changing the supply voltage, so approximately let me take in place of numerator instead of V minus IARA. So let me neglect this IARA and let me take only V in proportion to V by pi's relation. Now tell me your answer. Okay, tell me answer for this question. Very simple only. So whenever voltage, initially voltage is, I can say, 220 volts. Now he's changing voltage from 220 to 170 volts. That means, I mean, he's reducing voltage, right? He's reducing voltage from 220 to 170 volts. So obviously, what about the flux also reducing? No, because you know formula IS equals to V bar SH. Whenever V is reducing, IS will be reducing. No, yes or no? Yes. Whenever IS is reducing, flux also will be reducing. So simple relation here. As long as whenever your V is reducing here, V is reducing here. So no doubt IS is reducing, flux also reducing. So variation of your V, variation of your flux. If you take same amount of variation. So because he has not given RH square, all those things, right? So suppose if V reduces from 220 to 175, so numerator reduces here, denominator also of flux means it is depending on ISH. IS is equals to V by RSH. Whenever V is reducing, IS is also reducing, so flux is reducing. If both are reducing here, so that's the reason why I should take n value approximately what, guys? I can take n value approximately constant. Okay. So previously 1200 RPM. Now, so whenever voltage change from 220 to 175, in that case also your answer is 1200 RPM only. Option D is the answer. Okay, right. Let us see next question. A DC series motor driving an electric train faces constant power load. So guys, try to understand here. So actually, a DC series was driving electric train faces constant power load. So he's saying that mechanical load which is applied for the DC series motor is constant. So I can, let me write one point here. If mechanical load is constant, if mechanical load is constant for a DC series motor, I can say if mechanical load is constant, so then input power taken by the motor also, input power taken by the motor, I can say DC series motor also, input power taken by the motor is also taken as approximately constant. No, so try to understand here something simple as here. So whenever mechanical power is he has given constant, then input power taken by the motor is also taken as approximately constant. So guys, so generally, you know, DC series motor means you'll be having like this. So having armature relations will be here. So series field winding is connected in series supply here. Plus minus applied voltage is, I can say, V value here. I can say IL value, ISC value, RSC series field relations. I can say IA value. Okay. Can you please tell me what is the input power taken by the motor here? I can write V into IL, I can write, or V into ISC I can write, or V into IA also I can write. So please let me write here. Input power taken by the DC series motor. I can take it as V into IA. So guys, whenever mechanical power is a constant here, so whatever mechanical load applied to that motor is a constant. So let me take input power taken by the motor also approximately constant. So input power taken by the DC motor is VIA. Therefore, I can write here basically, I mean, correspond to the statement, I can write here V1 IA1 is equals to V2 IA2. Okay, I can write like this, very simple. Okay, and one more thing, yes, it is running at a rate speed at a rate voltage. So guys, initially it is running at rate speed means I can take n1 value here, n1 value I can take it as 1.0 per unit here. Okay, since rate voltage means initial rate voltage V1 is equals, let me take it as 1.0 per unit once again. Okay, next what is saying, if the speed has to be brought down to 0.25 per unit, then you just want to reduce the speed from 1.0 per unit to 0.25 per unit. Okay, 0.25 per unit. Then supply voltage has to be approximately brought down to. He's asking to find variation. I mean, what is the value of your V2? Okay, it just initially is running at 1 per unit and applied voltage is 1.0 per unit. So he just bring down speed from 1.0 per unit to 0.25 per unit. For that, how much voltage? What is the voltage? I mean, what is the voltage in the second case? What is the voltage corresponding to 0.25 per unit speed? Like this, okay? He's asking. Very simple question only. So guys, please try to understand. That means you have to find here V2 value. Okay. So please do one thing here. Please do one thing here. It is running initially is running at rate speed and rate voltage. The speed has to be brought down to 0.25 per unit. Then the supply voltage has to be approximately brought down to. Okay. So guys, please try to tell me. I'll ask one simple question here. In a DC series motor, I think n proportional to 1 by t is relation. So please try to refer characteristics of DC series motor. There will be having idea. So n proportional to 1 by t is relation for DC series motor. Please try to refer that. Now from that I'm asking, if you want n2 by n1 means n2 by n1 equals what I can write here? T1 by T2. And one more relation, T proportional to pi into Ia. That relation everybody knows that. Okay. And I told you one more thing. In DC series motor, flux proportional to Ia. This one also I told in this characteristics of your DC series motor. Please try to refer that. Okay. So pi proportional to Ia is relation before saturation. In saturation, flux remains constant. Generally, we are taking unsaturation region only, that without saturation, where pi proportional to Ia. Please try to refer pi proportional to Ia, how we are getting for DC series motor. Please try to refer characteristics of DC series motor. You'll be having some idea. Okay. Therefore, when pi proportional to Ia, so T proportional to pi into Ia is relation. I can write here T proportional to Ia into Ia. I can have T proportional to Ia square. We can write here T proportional to Ia square. We can write. Okay. What is the reason? Since pi proportional to Ia is the relation we know in DC series motor. So guys, please tell me N2 by N1 equals to T1 by T2. T1 by T2 equals what I can write? Ia1 square by Ia2 square. Yes or no? Okay, so very simple. So here he's asking to find V2 value, right? V2 value. So please tell me from this, if you want V2 value, V2 is equals to what I can write here? V1 into Ia1 by Ia2, by Ia2. Okay, so V2 equals V1 into Ia1 by Ia2. So I think you know V1 value. How much he has given? He has given 1.0 per unit, no? So 1 per unit. So thing is here you have to find Ia1 by Ia2. If you know Ia1 by Ia2, you can find out V2 value. Okay, so for finding Ia1 by Ia2 only, I am using this relation. So please try to see guys here. What's the value of N2 he has given in this question? 0.25 per unit. 0.25 per unit. What's the value of N1 he has given? 1 per unit. 1 per unit. So tell me from this, Ia1 by Ia2 is equals to what? Ia1 by Ia2 equals to, I'm just using this relation, these two equations I'm using. Ia1 by Ia2 equals to square root of 0.25. So we are going to have 0.5 is the value. 0.5 is the value. If you substitute this Ia1 by Ia2 value here, so you'll get 0.5. So what is your answer? V2 is equals to 0.5 per unit is the answer. So V2 value how much here? 0.5 per unit is the answer. Okay. So option B is the answer. Option B is the answer for this question. Very simple question only. Whenever mechanical power is constant for DC series motor, I took here input power taken by the motor also approximately I took constant here. So then V1 I1 equals to V2 I2 I can write here. So from this V2 equals to V1 into I1 by I2. V1 value already has given the question 1 per unit because it is running at rated speed and rated voltage. The rated voltage means I can take V1 as 1.0 per unit. Rated speed means I can take N1 value as 1.0 per unit. Okay. So you have to find V2 value. So So he's saying that if the speed has to be brought down to 0.25 per rate, the supply voltage has to be approximately brought down. If you want to reduce speed from from 1.0 per rate to 0.25 per rate, how much voltage I need to apply is asking. So okay, V2 you have to find out. So V2 I'll get V1 into I1 by A2. IA1 I'll already know 1 per rate. IA1 by A2 value you have to find out. For that one I'm using these relations. N proposed 1 by T is relation for T series motor. T proposed to pi into IA, where pi proposed to IA is relation for T series motor. So T proposed to IA square you are getting here, since pi proposed to IA. So N2 by N1 equals to, I can write T1 by T2. T1 by T2 equals to, I can write here IA1 square by IA2 square. So I'm using these two relations because we don't know torque concepts here. We know only speed and current. So N2 value I know 0.25, N1 value I know 1, and from this I can find out IA1 by IA2 as 0.5 per rate. If I substitute 0.5 in place of IA1 by IA2, you'll get V2 value 0.5 per rate. So your answer is B. Okay guys. So yes, right. This is, let us see in the next video, we'll proceed solving some gate questions once again. So actually in this question, if you see this question, this is a question asked in gate 2003 for 2 marks. And the previous question, this is a question asked gate 1999 for 2 marks once again. So this is a question gate 1998 for 2 mark. So this is a question asked gate 2015 for 1 mark. So this is a question asked gate 2015 for 1 mark, 1 mark. And this is a question asked gate 1999 for 1 mark. So this is the question asked gate 1993 for 1 mark. Okay. And this question asked gate 2005 for 2 marks. So guys, in the next video also we'll be proceeding solving gate problems in a DC machines. Thank you.